Assalamualaikum and good morning. Today, we are from Group M present the architecture of Microstrip circular patch antenna for application Wi-Fi that using a wide frequency 2.4 GHz. Now, we are going to show a 3 comparison scenario with a different substrate thickness and the present or absence of transformer in the feed line. In the first scenario, we are design the microstrip pitch antenna with a 1.6 mm substrate thickness of dielectric layer, and we put a transformer in the feed line. For the second scenario, we design the antenna with 3.2 mm substrate thickness of dielectric layer, but we did not put a transformer in the feed line. For the third scenario, same like a second scenario with a 3.2 mm substrate thickness of dielectric layer, but we put a transformer in the feed line. Now, we are going to compare a return loss between the 3 scenarios that we have discussed before this. In the first scenario, with a 1.6 substrate thickness and the present transformer in the feed line, the return loss is measured at a -2.24. In the first scenario, with a 1.6 mm substrate thickness and the present the transformer in the feed line, the return loss is measured at -22.4 dB and the bandwidth is wide. In the second scenario, with a 3.2 mm substrate thickness of dielectric layer, but without a transformer at the feed line, the return loss is slightly higher at -22.7 dB. But the bandwidth is a little bit narrow. You can see in this graph. Lastly, for the third scenario, with the same 3.2 mm substrate thickness of the dielectric layer, but with a transformer in the feed line, and the return loss is -29.6 dB, and the bandwidth is a more narrow than the second scenario. Now, we want to see the antenna gain for the first scenario. For the first scenario, the antenna gain is 2.229 dB. And for the second scenario, the antenna gain is 2.942 dB. And for the third scenario, the antenna gain is 3.026 dBi. This value indicate a slightly higher level of gain compared to the previous 2 scenario. Now, that's for me. Thanks.